What is up, everybody? Welcome to 6.1 Inverse Variation. Previously, when we were dealing with rational functions, we had these curves. We're going to be continuing with these curves, and these go to infinity and restricted domain and range. But this time we are dealing with rational functions instead. So there will be some vocabulary you might have to know. One of the first vocabularies that you will have to know for this thing is called inverse variation. Inverse variation is when one value goes up as another value goes down, and when multiplied together creates one number. So for example, graph the possible side lengths of this rectangle. It will be the possible side lengths. The area is 24. This is the area. The area is 24. So the possible side lengths. This is a graph of the possible side lengths. It can be 4 and 6. It can be 4.8 and 5. It can be 5 and 4.8. It can be square root of 24 and square root of 24. See, it can be a lot of these. That's why we have this type of triangle. As one value goes up, another value goes down. If one value is low, then the other value is high. And this is opposite from direct variation. A direct variation is when the graph is in a straight line passing the center. So as one value goes up, another value goes up by a constant multiplier. In this one, as one value goes up, another value goes down by a constant multiplier. And this the multiplier is and the constant is 24 in this case. We're going to start off with A. So we have 2 times negative 12, which multiplies to negative 24, and then 4 times negative 6, that's also negative 24, and then 6 times negative 24, negative 24. See? So even though they're both going up, so 2, 4, 6, 8, 12, 16, 4, 3, yeah, they're both going up. However, if we ignore the negative and you multiply them together, they still multiply to the same number. And if you add the negatives in, they'll multiply to the same number as well. So that is an xy equals negative 24 function right here. So it is inverse variation. This one, so it's 1, 2, 3, 4, 2, 4, 8, 16. So when you multiply these two, you get 2. When you multiply these two, you get 8. When you multiply these two, 24. So they're not inversely variated. However, when you multiply these two, 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is not 8. Therefore, they're not directly variated either. They're exponential. And because they're exponential, they're neither. This would be y equals 2tx power. So in exercises 15 to 21 through 22, the variable x and y vary inversely. So use these when to write an equation relating x and y, and find y when x is equal to 3. So when y is equal to negative 1, 6, x equal to negative 12, so we'll do xy is equal to a, right? Xy is equal to a, I already told you. So negative 12 multiplied by negative 1, 6, that's equal to a, and negative 12 multiplied by negative 1, that's 2. A equals 2. So the answer is y is equal to 2 over x. 2 over x. There you go. Same thing here. Xy is equal to a. 5/3 times negative 7 is equal to a. A is equal to negative 35 over 3. Negative 35 over 3. So now we have y is equal to negative 35 over 3. Y equals negative 35 over 3x. So the whole thing, the bottom is 3x. Okay, and this is going to be a short one because we only have one slide left. The number of Y songs can be stored in an MP3 player vary inversely with the average size X of a song. So a certain MP3 player can store 2,500 songs when the average size of a song is 4 megabytes. So if they can store 2,500 songs when the average size of a song is 4 megabytes, how much can they store in total? Well, that's 2500 multiplied by 4, that's 10,000 megabytes. 10,000 megabytes. And 10,000 megabytes, now, if you know computing terms, 10,000 megabytes is equal to 10 gigabytes. So 10 gigabytes. We have to make a table showing the numbers of songs that will fit on an MP3 player when average size is 2, 2.5, 3, and 5. So let's do it. Let's do 10 gigabytes. Let's just do 10,000, right? And then that's xy is equal to 10,000. Okay, xy doesn't fit. Xy is equal to 10,000. And then we'll show the graph of that. That will be x, y. Let's say x is equal to 2, 2.5, 3, and 5. So we have 10,000 divided by 2 is 5,000, 5k, I'll just put 5k. 2.5, that's 4,000. 3, that's 3,333. And then 5, that's 2,000. So as the song size go up, the amount of songs that you can store goes down, because that's an inverse variation. You can only fill a certain amount with this total amount of a certain amount of songs this size with this total storage amount that you have. Therefore, the amount of songs go down whenever the size of the song goes up. So next, using structure to balance the board in the diagram, distance in feet from each animal to the center of the board must vary inversely with the weight in pound. What is the distance to the animal from the fulcrum? Justify your answer. I really like this problem because it's a thinking problem. So fulcrum, this is the fulcrum, right? And then the distance in feet of each animal vary inversely with its weight. Must vary inversely in its weight in order to have a balance. So since it's vary inversely, we can multiply these two, and that's equal to the other weight that's being pushed on. So because it's the other weight, we have to also calculate this guy. So they vary inversely. So this multiplied by this, what's this section? This section is 6 minus d. So this multiplied by this has to be equal to this multiplied by this, because they both vary inversely from each other. So we have 7d is equal to 84 minus 14d, and then add 14d on both sides. 21d is equal to 84, and then d is equal to 4. So this animal is 4 feet away, and this is equal to 2 feet. See, so that's how balancing works. I think it's in physics. I'm not sure. I haven't taken physics yet. I might be teaching though. So that's gonna be it for today. See you later for the next episode.